Hello, I'm Chris Ellis of Ellis Talks, and I want to thank our sponsor, Intel, for making this video possible. The subject of this 10-minute tutorial is Gigabit Ethernet, and we'll be looking at it from two perspectives. First, we'll do a quick overview of how it works. And second, we'll look at the market drivers behind it. Gigabit Ethernet is fast. It's a huge pipe as data connections go. It can transport billions of bits per second, as Carl Sagan might have said. And it's a far cry from our ancestral roots in the early 80s when, like cavemen, we trudged data around on floppies via SneakerNet. So we'll start with the how it works section and look at the basic nuts and bolts of Gigabit Ethernet and see what gives it a leg up on other competing technologies. Then in the why section, we'll examine why companies are looking at Gigabit Ethernet. In other words, we'll examine the market drivers behind gigabit networking. So let's look at some of the technical highlights of Gigabit Ethernet, starting with the fact that it can run over copper. Now, the first version of Gigabit Ethernet only ran on fiber, but it wasn't long before the standards for running over copper were released. From a cost and deployment perspective, using copper for such high speeds is truly great news. Cat5 copper-based cabling dominates today's wiring closets, and the icing on the cake is that about 90% of the existing Category 5 wiring is Gigabit Ethernet ready. Now, there are few technologies with such a straightforward migration path that allows for a tenfold in speed without incurring the high cost normally associated with pulling new cable. Literally, take the fast Ethernet card out of your desktop PC or server and put in the Gigabit Ethernet card, and you're done. There's no protocols to install or hardware to configure, which is great news for your IT department. On the topic of copper wiring, Category 5 and the newer Category 5e enhanced versions work great with Gigabit Ethernet. Category 5e gives us better signal margins and is recommended for all new installations, but it isn't strictly necessary for Gigabit Ethernet. Regular Category 5 works fine, and the rule of thumb is if you're running fast Ethernet today over Category 5, then you'll be able to run Gigabit Ethernet over that same copper. In terms of distance, Cat5 and Cat5e can run for distances of up to 100 meters, which is typical between a desktop and a switch or a server and a switch. Now, for greater distances, there are fiber options, and both multi-mode and single-mode fiber are supported. It was possible to argue even just a few years ago that a PC could potentially never really take advantage of 1 gigabit, but many PC restrictions have overcome those kind of limitations, making gigabit a more obvious choice. For example, the movement of data between a computer's peripherals and the CPU has doubled, giving us data rates of up to 1 gigabit per second. And hard disk drive transfer rates used to be potential bottlenecks, but they too are much faster than their predecessors. And of course, their CPU processing power continues to leapfrog. We've witnessed increases from 1 gigahertz in early 1999 to 3 gigahertz and better today. And even if the average desktop application doesn't require a full 1 gig link, the more important issue here is that many desktops can and do exceed their existing fast Ethernet 100 megabit connection, making a bottleneck right at the desktop. So let's turn our attention to some of the drivers for Gigabit Ethernet and the reasons that businesses are giving this technology a closer look. One of the biggest headaches for the IT manager is that of users complaining about sluggish performance from their applications. It seems that networks like freeways during rush hour are never, ever fast enough. And I've seen freeway upgrade construction projects that take 2 to 3 years to complete, and yet traffic congestion at the end of that period is just as bad as when they started due to the natural growth of traffic over that same time. These problems add up to one fundamental challenge. How do you simultaneously solve today's congestion problems while assuring that you continue to build for the future and the next generation of corporate applications? This is a difficult challenge, especially given today's tight budget constraints. I recall a networking upgrade contract that I worked on about 6 years ago, and I remember how disturbed we, the networking group, became when the application development team informed us that each client-server transaction would be double the original estimates, from something of around 400 bytes to a whopping 800 bytes per transaction. Now, we naturally complained very loudly, seeing that that doubling of network traffic would have a negative impact on other applications and on the overall performance of the entire corporate backbone. Now, the application developers simply shrugged their shoulders and said, give the network more bandwidth, make it faster. Of course, we were incensed that we would have to fix what we perceived as being an application problem. But that very network-centric point of view doesn't deal with the simple reality that applications help increase business profits. Networks don't. Networks are often, unfortunately, perceived as being very costly and frustratingly slow. Simply put, companies don't exist so that they can build networks. They exist to make revenue, and corporate applications help to do that. Customer management applications, e-commerce, multimedia servers, and content-rich marketing messages being run from corporate web application servers. Now, if application performance is sluggish on your network, then there are a number of steps that you can take to alleviate that pain, and Gigabit Ethernet is a big part of that solution. While it's easy to imagine how Gig Ethernet can enhance a server, there are times you may need to have it go directly to the desktop. Now, my thinking on desktop performance is twofold. I have a short-term and a long-term strategy. The short term is to identify those individuals or workgroups that can justify the upgrade to Gigabit Ethernet now. That's the best bang for the buck because the incremental cost from a basic 10/100 megabit Ethernet card to a 10/100/1000 is reasonable, especially when you consider the fact that it runs over the same copper infrastructure that your fast Ethernet is running over now. So there's no cabling upgrades, no new protocols or adapters to configure or to tweak. My long-term desktop strategy is to identify that all new PC purchases come equipped with Gigabit Ethernet interfaces already on them, either built onto the motherboard or through adapters. Because this technology is auto-sensing, a Gigabit Ethernet-enabled machine sitting on a 100 megabit fast Ethernet link will only work at 100 megabits for sure. However, the moment you convert that segment over to Gigabit Ethernet, that desktop automatically starts transmitting at 1 gigabit per second. So staying within the Ethernet family of protocols has major benefits, including less IT staff intervention. There's no skills to upgrade on new protocols or technologies. Network upgrades incur nominal incremental costs versus major new expenditures or, worse, forklift upgrades, and there's little or no service interruption to the user community. So let's look at a sample network architecture and see how Gigabit Ethernet can be implemented in a phased approach. A great starting point is right here, the server farm and the backbone, which is where your data converges. If you think of your network as an old wagon wheel from the Wild West and your outer rim is your user community, then the center of that wheel is your data center or server farm. In essence, you start at the center of the wheel and work your way towards the desktop, deploying Gigabit Ethernet as necessary. Now, it's not hard to justify multiple Gigabit Ethernet connections into each of your high-demand servers because it immediately increases their network performance by levels of a factor of 10 or more. And with some of the newer PCI bus specifications, it's feasible to have data rates of 4 gigabits per second or higher per server. Now, the switches connected to the servers in the server farm should be upgraded to the appropriate blades or interface cards to support Gigabit Ethernet, whether they're layer 2 or layer 3 switches. Then upgrading the appropriate blades in the backbone switches to Gigabit Ethernet ensures that high performance levels are maintained throughout the core. Finally, the layer 2 segment switches that face your end users on a group-by-group basis can upgrade to Gigabit Ethernet as the segments or specific user desktops require it. It is normal for some users or clusters of users to have higher bandwidth requirements compared to other groups within your organization. The marketing department, for example, may have higher bandwidth needs given their multimedia mandate, while text-based administrative network segments may require less bandwidth. That will be a call based on traffic analysis done at the segment or link level, but if the desktops are already Gigabit Ethernet enabled, then simply connecting them into the new Gigabit access switches will jump them up to the new Gigabit Ethernet levels immediately. In summary, I want to reiterate some of the more important concepts that we covered today about Gigabit Ethernet. It's clear that almost all corporate applications are becoming more graphical in nature and certainly more bandwidth hungry, and this trend will continue as the various departments within a company understand and exploit multimedia and highly graphical applications to help leverage sales of products and increase revenues. Gigabit Ethernet can accommodate that traffic growth by increasing network performance by a factor of 10 or more, and it is a natural evolution from the 10 and 100 megabit versions of the protocol. Now, Gigabit Ethernet runs on the same copper infrastructure as 100 megabit fast Ethernet, making it a cost-effective way for the IT department to increase bandwidth and reduce congestion without excessive spending. And upgrading desktops, servers, and backbone switches with Gigabit Ethernet can be economical given the nominal cost increase of a 10-100 card versus a 10-100-1000 version. And finally, the plug-and-play nature of Gigabit Ethernet can reduce the workload on your already stretched thin IT departments. So this brings us to the end of this 10-minute tutorial. We want to thank our sponsor Intel for making this video possible. So I'm Chris Ellis of Ellis Talks. Please join us again.